Hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quant Coffee. I'm Aman, just welcoming you all to a new amazing video in which we are just going to talk about this integral. And now you might be noticing that I just took an integral which is pretty or maybe very easy to evaluate using by parts, right? But now you would ask, the one who always brings tougher or challenging questions or proofs, theories, and today he is just like playing around with this integral. Why so? So I will not leave my occupation for bringing difficult things, and still just believe me, you're gonna have a lot of things from this video. And basically we ain't gonna talk about the single method to evaluate this integral, that is by parts. Maybe it's one of those methods by which we can evaluate this easily, but I am not the one who teaches or learn easy things. We are here to learn difficult things, because easy things are being learned by everyone, but tough things cannot be learned by everyone. That's why. So firstly, let me just do this with the very first, that is the most basic di method, plus minus, taking the derivative of x and integrating e to the x. So the derivative of x is 1 and the integration of e to the x is just e to the x. So this times that, and this is inside an integral. So basically I is x times e to the x and minus integral e to the x dx, and that basically x times e to the x minus e to the x plus c. That's it. And now you would ask me, what's so special about this integral that you just made a video on this? Just wait for the moment. Actually, we are going to evaluate this integral with three different methods, and believe me, the third method will explode your brain, not in reality but in consciousness. Actually, you're not we I'm not Newman. I'm sorry. Okay, so yeah, next, this was the method 1 actually, right? And if I'm talking about the method 2, method 3 is, it's really interesting actually, because we are going to introduce some infinite series, and believe me, that is gonna tell us why we are wrong, or maybe I'm doing something wrong in that method. So I just want you to find that mistake that I did in the third method that I'm going to propose in front of you all. Wait for that moment. Method 2, right? So we were having I equals integral x times e to the x dx. Now I'm just going to use u sub. So the first method was the by we used by parts in the first method, but in the second method we are going to use u sub. So that is really cool. And what is that? Let x equals ln of t. So that is gonna say that dx is 1 over t dt, right? So I becomes integral x times, and from here we can say that e to the, I'm sorry, yeah, e to the x equals t. So yeah, right, just taking both sides e and all the stuffs in power. So we are gonna have e to the ln t is t, right? It's basic natural logarithmic identity, right? So no, I'm sorry, I just wrote down here x instead of t. So ln t and times e to the x is t, so I should write it here, and then dt over t. So here you can say that t and t getting cancelled out perfectly, and our life is easier. Integral ln t dt. And maybe you can use the by parts to evaluate this integral, but I have evaluated this, or maybe you can use the by parts to evaluate. So that's gonna be t times ln t minus t. So when you plug t equals e to the x here, so that's gonna give us x times e to the x minus e to the x plus c. So yeah, that's amazing. And these two like results are matching each other, so that's a pretty perfect thing, right? So these two methods were good, and we got to learn slightly things. It's very little, but now we're just moving on to the third method. So here I have just written that down earlier. I was just looking at it. Okay, let me tell you something. Actually, I was wondering about like and some kind of this kind of integral x times sine of x dx. So we always take this, we have to take the derivative of this one. But now I thought to why would I take the derivative of x? Why cannot I take the integration of x and rather take the derivative of sine of x? So exactly what I have thought here actually. Instead of taking the derivative of x, I have taken the derivative of e to the x, and I'm integrating x here. You can just see it right over here. So I'm just taking the derivative of e to the x and integrating x. So basically that's gonna give us the derivative of e to the x is just e to the x, so that's just kind of repeating each times. And the integration of x is x squared over 2, and 1 over 2 is a factor, and the integral of x square is x cube over 3, so that's gonna be x cube over 2 times 3. And when you integrate this one, so that's gonna give us x to the 4 over 2 times 3 times 4. When you integrate this one, so that's gonna give us x to the 5th over 2 times 3 times 4 times 5th, and so on and so forth till infinity. Okay, so when I'm just going to combine them, we do in di method like we do. So here we are having our first term is e to the x times x square over 1 times 2. Well, I can write that down to make it up some kind of factorial here, and this is 3 factorial, this is 4 factorial, that's why. And then minus e to the x times x cube over 1 times 2 times 3, and I've just written all the terms up to infinity, right? Well, I cannot write that down up to infinity, but I've just expressed it as, right? Okay, so now you can think that the odd like what I'm trying to say is the odd power of x is having a negative in front. Well, we can factor e to the x in from each term, so well, you can just think of it, right? E to the x is common, so we can just factor that out. And when we try to write these things in an infinite sum, like summation notation, so that's gonna give us the sum as n goes from 2 to infinity of negative 1 to the n times x to the n over n factorial, right? Okay, so basically we are having this thing. Isn't that cool? Because till now I don't think that I made any kind of mistake, but I'm not sure about infinity here. Maybe infinity is playing with us, and that is why I'm having a wrong answer from this method. Well, I'll tell you. So yeah, we can express this integral as e to the x factored out earlier, and this infinite sum. No, I'm sorry, I shouldn't have included that. Yeah, that's good. Next, well, we know that the sum as n goes from 0 to infinity of x to the n over n factorial is e to the x. And when you replace x with negative x here, so that's gonna give us negative 1 to the n times x to the n over n factorial as sum goes from 0 to infinity. So if I'm talking about the sum as n goes from 2 to infinity of this very sequence or series, so I have to write the first two terms like for n equals 0 and for n equals 1, and sum them together to get this sum. And that is what I'm looking for, because I just have to plug this down here to get rid of that infinite sum. So basically we are having e to the negative x equals 1 minus x plus this infinite sum. So we can write this down like this, and now we can just replace this thing with here. So we are gonna have e to the x as earlier we had and times this thing, and when you solve this, so we are having this one, and finally this is the final result. But the thing that we shouldn't have a positive one here, and that is why it's kind of something I think it's wrong, and I'm just looking for this question, what's wrong here. And believe me guys, I'm just learning, and maybe some of you are graduated, or maybe further you have studied further, but I am just in, well, I'm not just, I shouldn't be demean myself actually. uh, I've just passed grade 12th, so I'm not sure why I'm having wrong, but yeah, I'm in search of that. If I got to know, I will write that down in the description box. But if you know about this, why this is happening, so please let me know in the comment section, guys. I'm really confused about this. And yeah, thank you so much for watching this video, guys. If you got to learn something from this video, just make sure to like, share and subscribe. And yeah, let's get meet up in the next video. Actually, let me tell you something. I'm having something trouble in my feet, one of my feet, actually leg feet. So I'm not like properly, I'm not able to properly stand, so I'm not able to stand properly. So for that case, I cannot teach you on board, so I'm really sorry about that. I just have to continue teaching on this tablet itself. But yeah, sooner I'll get recover from that, so I'll just get back to the board because I love that. And yeah, so far it's good. Thank you so much for watching this video, guys. Actually, I said that earlier, I think. Okay, goodbye, take care.